Let us go straight to the questions that I gave and we see how we work them out. These questions were about hydraulic press, which you covered in Form 2. So let us just continue with revision, remembering that the work which is supposed to be covered in Form 2, Form 1 is very important to our study because they're going to be there in the forthcoming examinations. Okay, let us start without wasting time with question number 1, which was saying that a hydraulic press has a small piston of radius 2 centimeters and a big piston of radius 2 meters. How much force in newtons must be applied to the small piston in order to raise a load of 1,800 kilogram car? Okay, that was the first question. Okay, now when you talk about a hydraulic press, you're talking about the principle of transmission of pressure. That's what you're basically talking about here. In other words, the pressure that is going to be applied on one end is going to go to the pressure exerted on the other end. This is the principle of transmission of pressure, or this is Pascal's principle of transmission of pressure. Now we are saying that pressure, we have two pistons here. We have a small piston and a big piston. They've given us the radius of the small piston and the radius of the big piston. So we see that the small piston is having a radius of 2 centimeters and the big piston is having a radius of 2 meters. Now you observe here that they don't have the same units. And yet when you're tackling problems here, we are supposed to use the same units, especially if it is the same quantity as it is the case now. Now, the mass of the car is 1,800 kilograms. What does this mean? It means that the weight of this car is going to be 18,000 newtons. Why? Because you know that weight of a body is given by mass of the body times the acceleration due to gravity. So if we work it out and multiply the mass that is given to us by the acceleration due to gravity, we get an answer of 18,000 newtons. But if I say that the weight here is 18,000 newtons. But what are we looking for? We are looking for the force that is applied on the small piston. Okay? We are looking for the force applied on the small piston such that this piston, if the force is applied there, a car of weight 18,000 newtons can be lifted on the bigger piston whose radius is equal to 2 meters. Okay, so we know that the pressure is equal. Pressure at the small piston is the same as the pressure at the bigger piston. So, but pressure is given by a formula, force over area, meaning that the pressure at the smaller piston is going to be the same as force at the smaller piston divided by the area at the smaller piston. This is going to be the same as force at the bigger piston divided by the area at the bigger piston. Now, if we manipulate or we work out this, we rearrange, we put in the values that have been given to us, we find that F1, which is the force at the smaller piston, is going to be given by 180 newtons. Now the second question is telling us that in a simple hydraulic system, piston 1 has a cross-section area of 0.000050 meters squared and piston 2 has a cross-section area of 0.00025 meters squared. What output force is generated by piston 2? Now what you have to understand is that we have two pistons here. There is one piston where the effort is put or the input force is put, and there is the second piston where the output force is got. So here, in this case, we find that we are told to get the output force. What is the output force generated in piston 2? Okay, that means that piston 1 was acting as input force. That's why the input force is put, and piston 2, that's where the output force is put. In other words, piston 1 is where the effort is put, and piston 2 is where the load is lifted. I hope that is okay. Okay, so we come and say, we look at the data that is given to us. Our data, number 1, area of small piston is 0.000050 meters squared, and area of the big piston, A2, is equal to 0.00025 meters squared. The force used on the small piston is 500 newtons. Again, we use the principle of transmission of pressure. We find that F1 over area 1 is equal to force 2 over area 2. Now, force 1 is representing the input force. Area 1 is representing piston 1. F2 represents the output force, and area 2 represents the area of the second piston. Now, if we put in our values that have been given, we've been given 500 as the input force, and the area of the input is there, area of the output is here, and we are looking for this one here. If we manipulate using a calculator, you'll get that F2 is equal to 2,500 newtons. 3 is saying that a medium-sized car typically weighs 1,000 kilograms. A hydraulic system to jack the car up above an inspection pit has 4 cylinders, and the 4 slave cylinders whose pistons have cross-section area of 0.01 meters squared. The cross-section area of the master piston is 0.000125 meters squared. What is the weight of the car? That is question number 1. Question number 2, what is the minimum force that must be applied to the master cylinder piston to raise the car upwards? Okay. Now, for this part of the question, or for this question here, we're told that we have a car, and this car is having a mass of 1,000 kilograms. Okay, the first part is telling us to find the weight of the car, and we know that weight of a body is given by mass times acceleration due to gravity. And since we have the mass of the body, we have the mass of the car, we can be able to get the weight of the car, which is going to be given by 1,000 times 10, and that is going to give us 10,000 newtons. That will be the mass of the car. Then the second part of the question was telling us that to find the minimum force that can be used to raise this car here. Now, we have slave cylinders. What do you mean when you say slave cylinder? There is the master cylinder. Okay, this is where the effort is applied. Okay, here it's like when you're in a garage and a car is going to be lifted up such that you observe the down part of the car. They are observing down the car. Okay, maybe they're doing service to this car and they are trying to check it has a problem, it doesn't have a problem. There is a pit, or there is a point around many petrol stations or garages where a car is put and then it is lifted up. Okay, now there are 4 pistons that's onto which car is sitting at the 4 ends of the car. Okay, now the place where the force is applied to lift this car, that cylinder which is being used, is what we call the master cylinder. Then these 4 cylinders which are supporting the car as it is being raised up, or the ones which make the car to move upwards, those are the ones which are known as slave cylinders. Now, we have slave cylinders. Each one is having an area of 0.01. Okay, so if each one is having uh, an area of 0.01 meter squared. That means that four of them, all of them are going to have a total area of 0.04 meter squared. So we are saying here that the slave cylinders are used to raise the load, while the master cylinder is where the effort is applied. Now because they are four, okay, each one is having a particular area of 0.01. We're supposed to get the total area. So total area is going to be given by 4 times the area of one piston, which is equal to 0.01. And therefore we get a total of 0.04 meters squared. After that, we come and use our principle. Force 1 over area 1 is equal to force 2 over area 2. In other words, the force that is applied on the master cylinder divided by the area of the master cylinder. The answer I'm going to get is going to be equivalent to the force that is lifted up. In this case, it's going to be the weight of the car divided by the total area of the 4 cylinders, which is, in this case, is 0.04. And if you manipulate using our calculators, we find that our answer becomes 312.5 newtons. Number 4 is saying that, question number 4 is saying that the diagram below shows a hydraulic press being used to lift a container weighing 100,000 newtons. The radii of the effort and load pistons are 20 centimeters and 5 meters respectively. If the efficiency of the press is 90%, determine Roman numeral 1, the velocity ratio of the press, Roman numeral 2, the mechanical advantage of the press, Roman numeral 3, the minimum effort required to lift the load, and Roman numeral 4, the distance the container is raised through if the effort is pushed through 1 meter. Okay, that is our question. This particular question, they've drawn for us the diagram, and we can see this is the load that is supposed to be lifted up, and the effort is supposed to be applied this side here. Okay, so effort is applied here, and the load is going to be lifted this side here. So the first part is telling us to find the velocity ratio of the press. Now, how do I get the velocity ratio of the press? Of course, it is known that velocity ratio of a hydraulic press is given by the formula area of the large piston divided by area of the small piston. This is the same as saying radius of the large piston squared divided by radius of the small piston squared. It is the same thing because pi is a constant. The velocity ratio is going to be given by, here we have that the load piston is having a radius of 500 centimeters and the effort piston is having a radius of 20 centimeters. This means that the velocity ratio is going to be given by 500 squared divided by 20 squared, of course, which gives us 625. That is the velocity ratio of this machine. Then part B is telling us to find the mechanical advantage. To get the mechanical advantage here, we use the relationship between efficiency, mechanical advantage, and velocity ratio. That is, efficiency is the same as mechanical advantage divided by velocity ratio times 100%. That's what you are having here. Okay, that is our efficiency. But the efficiency has been given as 90%. So 90% is equal to mechanical advantage divided by 625 times 100%. If I manipulate this, I'm going to get mechanical advantage is equal to 562.5. Then to get the effort that is used to get the effort used, we use the relationship. Of course, mechanical advantage is the same as load divided by effort. So if I have the mechanical advantage, I have the load, I can be able to get the effort. And in this case, we get our effort as equal to 177.78 newtons. That is part C. Then lastly, part D. We are supposed to get, we are told to get the distance through which the the load moves through, or the load piston moves through, if the effort piston moves through a distance of 1 meter. Here we use the principle of conservation of energy, or principle of conservation of work, meaning that if I get the effort, I multiply by the distance through which the effort moves. The answer I'm going to get is going to be the same as the load times the distance through which the load moves. Principle of conservation of energy. The energy that is put in one side should equal to the energy that is got in the other side, assuming that this thing is 100% efficient. Okay, so we use this principle here, principle of conservation of energy, where work input should equal to work output. Okay, or we can again use that the volume that is displaced this side here, okay, the volume the fluid moves through at the side of the effort should equal to the volume that the load side is going to be raised by. Okay, so you can use volume at the piston, effort piston, should equal to volume at the volume raised at the load piston. Okay, so if you use that, we are going to get the same thing as what you're getting here. So force, that is effort times effort distance, should equal to load times load distance. Here we're saying where D1 is the distance the small piston moves through, and D2 is the distance through which the big piston moves through. If you work this out, we get 177.78 times 1 is going to equal to 100,000 times D2, from which we are going to get our D2 as equal to 0.0018 meters. Our last question is saying that a hydraulic press has effort and load pistons with areas 0.02 meters squared and 0.3 meters squared respectively. A force of 550 newtons is required to lift a car with a mass of 680 kilograms using the press. What is the efficiency of the press? Okay, now we have been given the area of the small piston, which I'm calling A1, and that is 0.02, and I have the area of the big piston that I'm calling A2, which is equal to 0.3. Now velocity ratio for a hydraulic press is given by area of the big piston divided by area of the small piston, or we can say the area of the load piston divided by area of the effort piston. So in this case, we have 0.3 divided by 0.02, which is going to give us velocity ratio as equal to 15. Okay, remember that the question is telling us to find the efficiency. If they've given me the area, the two areas, they've given me the load and the effort, it means that I can be able to get the efficiency of this machine by using the relationship efficiency is equal to mechanical advantage divided by velocity ratio times 100%. So we get first of all get the velocity ratio because we have the respective areas. Then we come to get the mechanical advantage, and I know that mechanical advantage is given by load divided by effort. Now what is the load? The load is the weight that is going to be carried on the load piston. In this case, it's going to be the car. Now they told me that the mass of the car is 680 kilograms. That means that the weight of the car can be got from 680, we multiply by the acceleration due to gravity, which is equal to 10, from which you are going to get 6,800 newtons. So if we have the effort which is equal to 550, then you're going to come and say mechanical advantage is equal to 6,800 divided by 550. This gives us a mechanical advantage of 12.36. Then lastly, we come and say efficiency is equal to mechanical advantage divided by velocity ratio times 100%. My mechanical advantage is 12.36. Velocity ratio is equal to 15. We multiply by 100%, from which we get our efficiency as 82.4%. Therefore, we say that the efficiency of this hydraulic press is equal to 82.4%. Okay, so this marks the end of this class. We shall start from there next time.